Hello everyone and welcome back to my channel. Today we're going to explore one of the most fascinating and scientifically complex aspects of human diversity: left-handedness. At first glance, handedness may seem like a simple preference, just the choice of using the left or the right hand. However, scientific research shows that handedness reflects deep biological processes, including brain organization, genetics, and human evolution. Around 10% of people worldwide are left-handed, which means that hundreds of millions of individuals experience the world differently in subtle but meaningful ways. In this episode, we will explore what causes left-handedness, how it relates to the brain, what advantages and challenges it may create, and what it reveals about human biology. Handedness is not simply a habit learned during childhood. It is closely connected to the structure and function of the brain, particularly a concept known as brain lateralization. The human brain consists of two hemispheres, the left hemisphere and the right hemisphere. These hemispheres are not identical in function. Each one specializes in different cognitive processes and controls movement on the opposite side of the body. This means the left hemisphere controls the right hand and the right hemisphere controls the left hand. In most people, the left hemisphere is dominant for language processing, logical reasoning, and fine motor control. This neurological dominance usually leads to right-handedness. However, in left-handed individuals, brain organization is often more variable. While many left-handed people still use the left hemisphere for language, a significantly higher proportion show language activity in the right hemisphere or distributed across both hemispheres. This difference demonstrates an important scientific principle. Left-handedness is not a defect, but rather a natural variation in how the brain develops and organizes itself. Neuroscientific research using modern imaging techniques, such as functional MRI scans, confirms that left-handed brains often show less rigid lateralization. This means that certain functions may be shared more evenly between both hemispheres, which reflects flexibility in neural organization. However, it is essential to emphasize that this difference does not imply superiority or inferiority. Overall cognitive ability, intelligence, and learning capacity are not determined by handedness. Left-handed and right-handed individuals perform equally well across the full range of intellectual activities. One of the most important scientific questions is why left-handedness occurs at all. Research strongly suggests that handedness is influenced by genetics, but not controlled by a single gene. Instead, multiple genes contribute to brain asymmetry, which in turn influences hand preferences. Studies of families and twins show that left-handedness tends to occur more frequently among relatives, indicating a hereditary component. For example, when both parents are right-handed, the probability of their child being left-handed is relatively low, around 10%. However, when one or both parents are left-handed, the likelihood increases significantly. This pattern demonstrates genetic influence, but it also shows that genetics alone cannot fully explain handedness. Prenatal development also plays a crucial role. During early pregnancy, the brain undergoes complex structural formation. Factors such as gene expression, hormone exposure, and neural connectivity influence how the hemispheres specialize. Interestingly, ultrasound studies have shown that some fetuses display hand preference even before birth. For example, by sucking their left or right thumb more frequently. This suggests that handedness begins developing in the womb, long before social or cultural influences occur. Therefore, handedness emerges from a combination of genetic predisposition and early biological development, rather than from conscious choice or environmental training. From an evolutionary perspective, left-handedness presents an interesting puzzle. If right-handedness is dominant in the population, why has left-handedness not disappeared? One widely accepted explanation is known as frequency-dependent selection. This theory proposes that left-handedness persists because it offers advantages in situations involving direct competition. In activities such as combat, sports, or physical confrontation, left-handed individuals may benefit from being less predictable. Because most people are right-handed, they are more accustomed to interacting with right-handed opponents. When facing a left-handed person, their expectations and reactions may be less efficient. This advantage has been observed in modern sports. Left-handed athletes are overrepresented in interactive sports such as tennis, boxing, baseball, and fencing. Their relative rarity creates an element of unpredictability, which can improve performance in competitive situations. From an evolutionary standpoint, even a small advantage in survival or competition can allow a biological trait to remain present across generations. This helps explain why left-handedness has remained stable at approximately 10% of the population for thousands of years. Scientists such as Chris McManus argue that handedness represents a stable biological balance rather than a problem that evolution needs to eliminate. Although left-handedness is biologically normal, left-handed individuals often live in environments designed primarily for right-handed users. This creates practical challenges in everyday life. Many tools, devices, and educational environments are optimized for right-handed use. Examples include scissors, writing desks, kitchen equipment, and even computer input devices. These design differences may require left-handed individuals to adapt their movements, which can lead to discomfort or reduced efficiency. In the past, some educational systems even forced left-handed children to switch to their right hand. Modern neuroscience strongly discourages this practice because it interferes with natural brain organization and may cause stress or learning difficulties. Fortunately, awareness has increased significantly. Today, educators, designers, and manufacturers recognize the importance of accommodating both left and right-handed users. This shift reflects a broader understanding of human diversity and neurological variation. One of the most persistent myths about left-handedness is that left-handed people are either more creative or less capable than right-handed people. Scientific evidence does not support these extreme claims. Large-scale psychological and neurological studies consistently show that intelligence levels are equally distributed among left and right-handed individuals. Handedness does not determine a person's intellectual potential, learning ability, or academic success. Some studies suggest that left-handed individuals may be slightly more common in certain creative professions, such as art or music. One possible explanation is that differences in brain lateralization may encourage diverse cognitive strategies or flexible thinking patterns. For example, the Renaissance artist and scientist Leonardo da Vinci was famously left-handed. However, it is essential to understand that creativity is influenced by many factors, including personality, environment, education, and motivation, not handedness alone. Left-handedness should therefore be understood as a biological variation, not a predictor of ability or talent. Left-handedness provides valuable insight into how the human brain develops, adapts, and evolves. It reflects the complex interaction between genetics, prenatal development, brain structure, and evolutionary forces. It demonstrates that human biology does not follow a single rigid pattern, but instead allows for natural variation and diversity. Importantly, left-handedness does not represent a limitation. It is a normal expression of human neurological diversity, shaped by millions of years of evolution. Perhaps the most meaningful insight is that left-handedness reflects the natural diversity of the human brain. It shows us that there is no single way for the brain to develop or function. Instead, the human nervous system allows for multiple patterns of organization, each equally natural and biologically valid. By studying left-handedness, scientists gain deeper insight into how the brain forms connections, specializes its functions, and adapts over time. In this way, handedness is not just about which hand we use, but about the remarkable complexity of the brain itself. Thank you for listening. If you enjoyed this episode and would like to explore more topics while improving your English, feel free to join me again in the next podcast. Until next time, stay curious and continue your journey of learning and discovery.